Okay, so the first thing we need to talk about is we're entering a new chapter, and polynomial. We need to talk about what that is, okay? The prefix poly, does anybody know what that means? What? It could mean 5. It doesn't give a specific number. It just means many, okay? Polyester is like a material from like the 70s that's made up of a bunch of different types of fabric. It's a little bit of rayon, a little bit of cotton. It's like the worst material ever. But poly just means many, okay? So chapter 7 is a chapter on polynomials. So there are things called monomials, binomials, trinomials, and then after that, you just go to polynomials. Okay? So here are our prefixes. Mono, it didn't dry yet. Bi, tri, poly. Okay? That's a mess. Mono means 1. Bi means 2. Tri means 3. Poly just means 4 or more. Okay? And we've seen these examples in our daily lives. Okay? Mono, like a monocule, or I never know how to say that. You know, back in the olden days where the ladies would be in the upper balcony of the opera and they'd put one little, binocular, except it's not a binocular, it's one. It's a monocule or binocular. What is it called? Monocle, yeah. So binoculars to bicycle, okay? Tricycle, triangle, and then poly just means many. So a monomial is basically a term that is made up of coefficients, variables, so like 3x. That's a monomial, okay? It could be made up of just a variable. It could be made up of just a constant. It could be made up of a variable and a coefficient. It could have exponents in it. It's just basically something that stands alone, okay? Examples of binomials would be like 4a minus 7 because there's 2 monomials. Do you get it? So a binomial has 2 monomials. Okay? A plus 7y is another example of a binomial. Then a trinomial would just mean you have 3, like 7a plus 6y minus 7. That's a trinomial because there's basically 3 terms, okay? And then obviously a poly would just mean you have 4 or more. So if you have 13 terms and if you have 5 terms, it's just called a polynomial. But here's the weird thing. These are all called polynomials. So it's kind of like, you know how when you have an outline, you have a Roman numeral 1, and then these are your A, B, C, because these all fall under these, right? So these are all referred to as polynomials. Okay? All right, so to give you an idea, that's just a real quick thing of, we're going to talk about degrees, standard form, but not just yet. So today we're going to add and subtract these things. All right? So we could start with a monomial plus a monomial. Pretty easy. Like if I were to say 5a plus 6a. Well, the first thing you think is, hey, this is just combining like terms, isn't it? Haven't we just done this before? Yeah. And you can combine them, remember, as long as your variable part is the same, correct? But the difference that you're going to see here today in polynomials is that polynomials can contain, as you saw up here, exponents. All right? And it's almost like a cruel joke, the people who wrote this book, because you just came off of chapter 8, where you were adding the heck out of exponents, weren't you? Right? When you multiply, you add. So if I asked you to do 5a squared times 6a squared, you would tell me it's 30a to the 4th, right? Because it is. But if I were to turn around and ask you to combine these or add these, and if I were to say, hey, I have 5a squareds, now I get 6 more a squareds, you know what? You still have a squareds, don't you? Now you just have 11 of them. So you kind of need to retrain your brain right now and say, okay, I just got done doing a whole 3 weeks of adding exponents, then multiplying them, sometimes subtracting. Guess what? Not anymore. You're done with that for right now. Okay, at least for this section you are. So when you are combining, which means adding or subtracting, the weird thing is you don't add them. Okay? Now if I were to say 5a squared and 6a, do you think those are like terms? No, they're not, because in order to be like terms, they have to have the same variable part, which means what's after the coefficient has to be identical. And I know this one has an a and so does this one, but they're not identical. So you can't really combine that. You just have to say that if I have 5a squared plus 6a, then it means I have 5a squared plus 6a. That's really your answer. Okay? So when adding or subtracting polynomials, do not add the exponents, okay? Do not add the exponents. So something new there to keep in mind. All right, so let's start out with this. The first kind of problem you're going to see is a trinomial plus a trinomial. So let's talk about adding them first. So if I were to take the trinomial 2x cubed minus 5x squared plus x, and I ask you to add that to this trinomial, 2x squared plus x, is that the one I gave? Plus, or minus 1. Okay. Oh, hold on. I messed up on that. Cubed, squared, 1. So this is going to be, we're going to make this a 3. Just make that a 3. Make that a squared. Yeah, we'll do that. Okay. So as I'm looking at this, I see a plus. I basically see 3 monomials here and 3 monomials here. So because it's a plus, the parentheses don't really even need to be there. You can just start combining like terms. So I have 2x cubes, right? So if I have 2x cubes here and 2 more x cubes here, that gives me 4x cubes, right? And it's almost kind of like there's a lot to look at, so you may want to just kind of cross that out of the way when you're done with it, so your eyes don't have, to look at so much. Next, I have a negative 5x squared and a positive 1x squared. What would that give me when I combine that? A negative 4x squared, right? So now I've combined my x squared terms. Now I'm looking for my x terms. I have 1x here. No x's over here, so what would that mean for my answer? Just an x, and then the minus 1, and that is your answer. So I added 2 trinomials and got a polynomial, 4 or more terms. That's all there is to adding, okay? So let's take a look then at what it would mean to subtract. What if I wanted to take this exact same 2 polynomials and subtract them instead of add them? That would mean I have 2x cubed minus 5x squared plus x, and this time I want to subtract them. 2x cubed plus x squared minus 1. Well, first thing you have to think about is changing this one little thing, this plus, to a minus is pretty major. It's going to totally change how you do this problem. So when you subtract a monomial, all right, that just means you're subtracting a 2x cubed, but you want to subtract the whole expression. So what do you think I have to do? So it's not something new that we've never done before. I have to do this. So I'm going to take this 2x cubed, this, and subtract a 2x cubed. And then what is the opposite of a x squared, a positive x squared? It becomes a negative x squared. And then this negative 1 times this negative 1, because that's really what it means, becomes a plus 1. So let's step back a second and see what multiplying by a negative 1 does. It takes the opposite of the expression. So if I were to say, what's the opposite of this expression? You would say, well, the 2x cubed was positive, now it's got to be negative. This was positive, now it's negative. This was negative, now it's positive. That's what the effect of multiplying by negative 1 does. Now can you combine? Yes. So now what are you going to get with a 2x cubed and a negative 2x cubed? They cancel, right? So should you put a 0x cubed? Nah, you know by now. So that just cancels. Look, it was 4 before. Now I have a negative 5x squared and a negative 1x squared, which is negative 6x squared. And then I have still the plus x, but this time it's a plus 1. So do you see the difference in when you subtract? When you subtract, you must distribute to the second set of parentheses first, then combine. So distribute the negative 1 first, which then changes the sign of the whole second parentheses, then go ahead and do your combining. CLT, you know what that means, combine like terms. So I got two different answers, okay? Got it? Now, I want you to notice the way that I put my answer. It had the highest exponent first, then the next one, then the next one, and all the way down to that didn't have any exponents, okay? So that's something that we're going to call standard form. So the standard form of a polynomial is how you should put all your answers. It's the highest exponent all the way down to the lowest exponent, and your constant should always be last, okay? So what if they ask you to combine or subtract? Hello. Okay. Okay, no. Absolutely, yep. Okay. That's okay. That's okay. Cool. And this third. Yep. Okay. Cool. Thank you. Okay. Bye. Sorry about that. So highest down to lowest. If I were to say combine these two binomials like an x minus 3x to the fourth minus an 8x plus 7x to the third. Okay? So it's kind of all over the place. Yep, Joe.
The one before this one, why would it be a negative 6?
Because the 5 is negative and the 1 is negative. And a negative plus a negative means you just have more negatives. That's all. Okay? So the first thing I'm going to do is distribute this, which is going to make this a negative 8x and a negative 7x cubed, right? Now, I look for my highest exponent. It's 4. Do I have any other 4s to combine it with? No. So that's just going to give me a negative 3x to the fourth. Do I have any x cubes? Do that next. So you're literally just kind of putting it in order, even though it doesn't appear in that order, okay? Then I have my x. Do I have any x squareds? No. And then I have a negative 7x, and that's going to be your answer. So standard form of a polynomial is how you should put your answers. That's how the answers will be in the back of the book. That's the form that I'll be looking for on any tests and quizzes that you take, okay? Technically, is it wrong if you have a negative 7x, a negative 3x to the fourth, and a negative 7x to the third? No, because we know that addition is commutative, right? That property says that the order doesn't really matter. Is this the same answer as this? Yeah. But when they specifically come out and say, put your answers in standard form, you'll probably get a half a point off for it technically having the right answer, just not in the correct form. Understand? Okay, so you are going to breeze through